Are you spaced out? Are you wondering what's going on in space? Well, we're here to answer the questions. Most of our space weather here on Earth is a result of activity from this object right here, known as El Sol, the Sun, and who knows how many countless other names. Helios. We've got a large sunspot rising up in the northeast, right here. It produced a few C-class X-ray intensifications yesterday. Sunspot 2858, which is this one here, looking very weak. It may lose its name today. It has all but lost all of its umbrae. We also saw C-class intensifications coming out of this setting region in the northwest over here. Lots more imagery to come, including this 171 angstroms view, and we're going to have all kinds of close-ups for you here. Spectacular imagery once again today. Our coronal mass ejection warning has still not expired. It's taking its good old time to eject this filament. We'll show you that as well. First, here's this setting active region as well as sunspot 2858. As it breaks down a bit. Spectacular imagery there from our dynamic closest star. Here's this active sunspot rising here, and it's a quite large set of umbrae there. As we can initially see, it looks like it's only got one polarity, but I wouldn't be surprised to see this change. This could indeed be a beta-class sunspot. Likelihood of solar flares goes up a little bit with this. Here it is in a different wavelength. This is 131 angstroms. And you can see some C-class intensifications from that active region there. And last but not least, here is 94 angstroms. Great views of iron ionized iron and its ultraviolet emission spectra. All right, the radio flux has risen to 78. So we got very close to zero sunspots there once again, but now we've definitely got another sunspot rising. It'll be sunspot 2859. It's a return of an old active region. Here's the one-year chart of the radio flux. The black line is that. Radio flux at 78 solar flux units. And we are getting another weak intensification of the solar wind here from a coronal hole wind stream. We can expect to see the solar wind speed rise today. And before we get to that data, let's look at global seismicity. So if you're wondering what earthquakes are shaken, so am I. Here's the 90-day bar graph, and here's the USGS list. This area in the South Sandwich Islands remains the most active seismic region on the planet. It's a pretty spectacular amount of earthquakes from this area. This area near the tri-boundary of the South Atlantic, South Pacific, and Antarctican plates. Continues to shake and shake and shake. Some quakes around southern Alaska as well. So nothing over a 5 magnitude range. Very deep quake at Fiji, a 4.3 magnitude at 632 kilometers depth. Also, the Solomon Islands saw a deep quake at a 4.8 magnitude. Depth of that estimated to be 142.7 kilometers. So nothing outside the 5 range here. It looks like all low-level 5s were the strongest quakes of the past 24 hours. China saw a 5.9. The Band AC saw a 4.5 at depth. That's 155 kilometers. Also Russia. Near the Kuril Islands, south of Kurilsk, Russia. So fairly calm, seismically speaking. There was a deep quake at Tonga as well. That 4.5 magnitude quake estimated to be at 151 kilometers depth. Looks like a volcanic downtick also happening here, folks. Although Shivaluch on the Kamchatka Peninsula still exploding, 15,000-foot ash plume from it. Suwanosejima, flight level 080. It's an 8,000-foot volcanic ash plume. No volcanic ash observed from Fuego in Guatemala. Don't assume that it's not erupting. It could be a cloudy day on the satellite. Sangay in Ecuador exploding. 19,000-foot ash plume of volcanic ash over that caldera. Revenador in that same country of Ecuador exploding, 15,000-foot ash plume from it. And Sabancaya exploding as well. 24,000-foot ash plume from the Peruvian Sabancaya volcano. Please don't pole vault the caldera. Visit our website. Pick up some merch. Tell your friends and foes about the channel. Support the channel via the Smash team or by becoming a patron. You can find all the links at smashamash.com. By the way, here's our latest Patreon post, and I wanted to remind everybody that some of our Patreon posts are indeed public. So this one is talking about our latest Smash team post, and you, all of our viewers, are invited to join the Smash team. So there are already 4 levels of Smash team membership. There's a bronze level, which is just like unpaid patrons. There's also a $2.99 per month silver level, a $9.99 per month gold level, and then there is a $109.89 paid up option, which is equivalent to about 4 free months. You get a free exclusive piece of merch that nobody else has access to, and you can join at any time at smashamash.com/smashteam. We figured we'd include a Patreon post, a rare Patreon post. Also, smashamash.com/forum will remain free for all, just like the bronze tier at smashamash.com/smashteam. So thanks to our patrons. It's partially you who made it all possible. Also, our patrons and Smash team members are increasing the probability that these videos will continue to exist, remain publicly visible, and free for all to view at places like YouTube. So thanks again to all of our contributors, whether you're a one-time donor, thanks to you as well. Thanks to our patrons, etc. Here's our latest post at the Smash team. And it's just about this large sunspot group rising, so we included the high-res imagery in the intensitygram and the colorized magnetogram. So lots more posts coming there, and we don't have anything against Patreon. We're just in need of our own freedom to sort of go our own way and use the software for whatever we want. So you can see we did see some flaring, and we captured some flaring on the Twitch channel. We'll get to more of that later. Also, make sure you check out our meteorology segments if you haven't. They've been a regular feature on our playlists at youtube.com/smashamash/playlists. So a few C-class intensifications here. One was like a double peak, and it was pretty significant. That in the mid-C range there, largest flare was that one at 1600 Universal Time. Yesterday, we streamed it live to twitch.tv/smashamash. There are 20 hours of solar imagery over there. So here's the GOES proton flux, no spikes in that, no coronal mass ejections headed Earth's way. Some coronal hole wind is headed Earth's way, and some is already arriving, really. Here's the GOES magnetometer over the past 3 days, and Earth is just moving into a South Pole current sheet. So if you see some spiky sawtooth patterns in this, that could be the crossing of the heliospheric current sheet polarity boundary, the polaric boundary crossing. And you can see it here on the top view ecliptic plane field plot. Here's a North Pole current sheet, and coming is a South Pole current sheet right over here. Let's bring up the latest image. Here's the latest image. This data 1 hour and 5 minutes old. Earth is just about to snap into a South Pole current sheet. Not all that surprising, and we expect Earth to remain there for the foreseeable future. Here's the line of sight ecliptic plane field plot, and it's showing these shifts in this blue line here. That's an indication of the BZ, the top pane in the solar wind component that we show daily. It's not equivalent. It's giving us insight into where the BZ is, as both solar polar fields contribute to the total field strength. Next, the line of sight coronal hole plot. Since we've got a very well-defined North Pole coronal hole here shown in green, it's just moving into the Earth-facing zone now. We can expect a significant coronal hole wind stream from that, a fairly good signal in about 4 days. Also some South Pole coronal holes stretching up here toward the equator. And we have been putting up statements about the next 60 days. We're going to see a big increase in coronal holes. So here's the solar flare probability, and it does go up with the rising of that major sunspot in the northeast. It's not showing up on that computerized imagery yet, so we'll just move on. KP index only at 1. Global geomagnetic calm conditions here. And here comes the real-time solar wind. And so here's another weak coronal hole wind stream. So we saw this little intensification in the density, just pretty minor, making it up to just over 16 protons per cubic centimeter, and now dropping back down. So we can expect to see the solar wind speed rise here. And it's the standard signal of a coronal hole wind stream. Nothing too exciting going on there. Current solar wind velocity 344 kilometers per second. Solar wind density 8.33 protons per cubic centimeter. We also did see a rise in the plasma temperature, so it's a bit of a warmer plasma. It's actually quite hot. Anyway, next looking at geospace. And our geospace magnetosphere movies are not going to load today. It could be a problem with the University of Michigan website. The data you're seeing there is like 8 hours old from when we recorded the video. And at the moment, we were seeing quite homogeneous pressure here all around the planet. Geospace Delta B is not going to show up either. These are from the same web server, I would imagine. No Geospace Delta B imagery for today. So here's a diagram of the solar system. Full moon coming tomorrow. Let's advance this 1 week to show viewers where things will be in a week. And it's a fairly good bet that's where things will be on August 28th. Next, in-the-sky.org. We've created a star chart here. The yellow line is the ecliptic. The blue line is the galactic plane. And the sun has just risen here in Lehigh Valley, Pennsylvania. Today's cosmology segment will be very truncated. We're only going to show you and it's included in the daily space weather video, not a separate segment, although check our cosmology segments. It's also in playlists, youtube.com/smashamash/playlists. So we're looking at Jupiterian moons here, the Galilean moons as well as the Jovian moons. And I frankly have no idea which is which. I'm just going to show you the spectacular imagery of Jupiter. If you want to check this out yourself, you can find it at apod.nasa.gov, the astronomy picture of the day. And you can see some setting moons, some eclipsing moons, and hey, Jupiter's a pretty interesting environment. It's got one huge magnetosphere. Did you know that if Jupiter's magnetosphere was visible from Earth, it would be about the size of the full moon? When Jupiter only looks like a small point of light, it's got a huge magnetosphere. It's got like 90 moons, 89 or something moons, something like that. And it's quite an interesting system. The largest planet in the solar system. And some meteorological information, by the way. The Great Red Spot is actually not a storm. It's an anticyclone, a high-pressure zone. So while it does feature high winds, the same way high pressure is accompanied by high winds on Earth, it's not what you'd call a storm. A storm on Earth would be a low-pressure system. And again, if you want to find these images yourself, just head to apod.nasa.gov. And once again, that's a highly truncated cosmology segment. It'll not be a separate video, but there are like 220 cosmology segments, so check them out. Next, looking at electrons surrounding Earth, we don't see any charging hazards. Here's the one-year chart of the electron flux. Nothing to write home about there. And we see cratered levels of electron flux here as there are sporadic coronal hole high-speed winds showing up. which does typically crater the electron flux. There it is over the past 3 days. And here's the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. And NOAA forecasting even lower levels here, probably the onset of additional coronal hole wind. I would tend to agree with that forecast. There's a diagram of Earth's Van Allen belts. Did you know most of the electrons are in the inner Van Allen belt? Although the outer Van Allen belt has some too. Distances shown here in miles. And here's the total electron content showing you the electron density for the entire air column. We typically see the most chaos in this when we see coronal hole wind streams. Current conditions are pretty normal there. And for you new viewers, most GPS errors occur around the equator around noontime. Things looking pretty normal here in terms of the total electron content. Next, another diagram of the atmosphere showing you distances in kilometers, penetration of electromagnetic radiation, as well as thermospheric temperatures and molecular densities. But most importantly, it's showing you where the F ionosphere layer is at about 300 kilometers of altitude. Here is the latest data on that. So there you go. There are the vibrational frequencies of the ionosphere, at least the F layer of it. And each one of those blobs represents 1 megahertz difference in vibrational frequency. Megahertz are millions of vibrations per second. And we'll bring up the latest image and show you the anomaly map as well. Things aren't looking out of the ordinary to me here. Here's the anomaly map. And you're going to see most anomalies showing up around the South Atlantic anomaly, which is pretty much over the center of the South American continent. The South Atlantic anomaly, now more like the South American anomaly. And we're mainly seeing low-frequency anomalies here over southern South America, the North Canadian region, some high-frequency anomalies over the Central Atlantic, and a little bit in the Central Indian Ocean. Here's the latest image that's from 10:30 Universal Time. There's the ionogram, and there is the anomaly map. All right, so if you haven't been watching our meteorology segments here at the Smash News Network, least busted name in news, maybe check them out. They're pretty splentacular. There's a teaser. Let's do bonus features. All right, now we're looking at the National Sunspot Observatory facility in El Teide, Spain, the ground-based solar observatory here, to see massive filaments still in place, coronal mass ejection still not expired. Massive filaments down here, filaments over here in a prominent sort of a feature, and the main filament up here. It's huge. It's stretching all the way around the limb, and it still has not disconnected. We are just awaiting that. Still currently attached, it looks like. Here's the latest on the NASA GOES 16 solar ultraviolet imager. This is 284 angstroms. And we're just showing you to give you a diversity of wavelengths here, a little different wavelength for you there. 284 angstroms. Here's the current intensity. This is actually the show prep intensity gram, so that's what it looked like when we did show prep. This new Sunspot 2859, and there it is now, looking pretty similar. Let's see if we can figure out if it's alpha class or beta class. So when we bring up the colorized magnetogram and we rock it back, I think it's actually beta class. If it's beta class, it represents a huge difference. Nope, I think I only see North Pole umbre there, so I'm fairly sure that this is north, and this small trailing umbra is also north. So if that's a alpha class sunspot with only one umbral polarity, the likelihood of solar flares really doesn't go up all that much, but we'll be keeping an eye on that since it's not fully risen yet. And when I say ion, well, the pun is intentional. So here's just the northern hemisphere, and we've brought up 304 angstroms to show filaments and 193 angstroms to show this well-defined North Pole-oriented coronal hole system right here in the middle of your screen. Also some great views of some filaments in the northwest. Waiting for this filament to either erupt or collapse, or maybe it'll just stay there and rotate all the way around. They usually don't do that. And it's probably not going to have the capability to do that, as there are protons, solar protons, blasting out of this coronal hole right now. And they're sort of headed our way. Again, you can expect a coronal hole wind stream from that, a fairly well-defined one, a good signal, in about 4 days, 3 to 4 days. And here's a zoom out of those same wavelengths. More spectacular imagery today. Thanks again for tuning in, viewers. Congratulations on realizing the existence of our channel. Don't forget to visit our links, join the Smash team, pick up some merch, etc. Press like, subscribe, and may that solar wind be at your back.